Hi, welcome to another video. In this video, we will be talking about cycloconverter. As you can see on the left hand side, we have got a schematic diagram. On the right hand side, we have got an input AC waveform, and knowingly we have given the two different AC waveform, and we are getting the output even though the switching patterns are different. So to understand that, the schematic diagram, as you can see that at a particular instant the dot conventions are over here. At a particular instant we have a positive on the dot side, right? So the thyristor P1 is forward biased, and another thyristor which is forward biased is N2. If P1 is forward biased and we give a gate pulse, we can get a current from phase to neutral. And if N2 is forward biased, and if we get a current, we can get a current from neutral to phase. And also we can have in another instant when this side is negative and this is positive, we have got a positive at these two ends. So when these two is positive, the option is either the return is possible through N1, or the return is also possible through P2. So in this way we can have the options in the negative half. Overall, we can understand that if we want a same phase of the input, we are going to use P1 and N1. These are named as P1 and N1, and in the like we have also given the name as 1, 2, 3, and 4. The reason is the switches the in the hardware, the pulses are like in sequence like 1, 2, 3, 4, and in the power module it is mentioned in this way. Anyway, so we have got another. Let us understand this. What we can see is that if this input and the output pattern is same here and here, I am using the first and third, and the switching this first and third switches are used. The moment I am using 2 and 4, that is the input and output are out of phase, I am using the switches 2 and 4. These 2 and 4 are nothing but the lower two switches. That is what, when you're using the upper two switches, you are having the in phase, and when you're using the lower two switches, you are actually changing it. You are changing the it out of phase. And now if you are using, instead of 1 2 4 3, you are also using 1 3 4 2, then when you use a 1 3, obviously the pattern will be the same as input, so output pattern is same as input. The moment you use the 4 and 2, see here 4 and 2, it will be reversed. So when it is reversed, you can see the reverse portion over here for the reverse portion over here. So that's why these switching patterns works. Now what we will be seeing here are simulation results, and the simulation what we have done, there is a center trapped transformer where we have got a dot conventions as is the usual way. So as we see in the schematic diagram, and the green color is for the P1 P2, and this blue color is for N1 N2. And we know if we are using this, we are actually giving in phase of the input. So you can see that these two, okay, at so these two are in parallel, and there's a dot over here, and this is connected to this red one. Another one, these two, there's a dot over here. Here it is actually, he is seeing it as this black one. So what you can observe here is the red one is in phase with the input, and the black one is out of phase with the input. So this to remember. Now if you take this, you can see that the input is, you can see the 100 is the peak, and since it is a midpoint tapping is there, so the output your in phase is 50, and also you have got out of phase that is also up to 50. Now let us see these three things together, or four together. So what we can see, the pattern is 1 2 4 3. That means 1 2, then 4, then 3. Okay, and 1 3 is belongs to these two, correct? And these two is actually, their input is the waveform like this, and 1 3 is belongs to this. So what exactly we are getting the output at 1 3? The output at 1 3 will be here. This is the output at 1, and 3 will be output as here. These two are the output for, no, 3 will be over here. This is 1, and 3 will be over here. So I will draw it over here. This is the input 1 and 3. So you can see that the 1 and 3, the input is just like copied over here. This and this. So 1 and 3, they are just copying it. So what else? Another is one is 2 and 4. When you use 2 and 4, this lower two thyristors. So these two belongs to the, they are seeing the input as of this black waveform. Input means at over here as of this waveform. So 2 and 4, where is this? 2 is this, and 4 is at this one. So 2 and 4, 2 and 4 is like this middle one, right? So 2 and 4. So these are out of phase with respect to input. See that? So that is what 1 2 4 3 can be the pattern. The pattern is possible that 1 3 4 2. That is also possible, as it is like when you go for 1 and 3 together, we are just copying these two first. Here, see that 1 and 3. Again, when we copy this, take this 2 and 4 and 2, pattern is 4 and 2. Then we are just doing the reversal of the input. Can we see the input over here? Yes, reversal of this input. So you just 180 degree out of phase, 180 degree out of phase. So that's why 1 3 4 2 is okay. Like that. So these two patterns are allowed. These two patterns gives us the good results. And like the point is here, if we see both the waveform together, right? If I see this is the output waveform when the pattern is on this way, another pattern is this way. So between these two output waveforms, when you see in the DSO or the CRO, so you are not able to judge it which one is which belongs to what, because if you have the input and the output together, then only you can have idea. Else, if this waveform look like this and here also it is look like this, so both will look like the same. So it is the same waveform. So in the hardware, you can see that here we get the output waveform, and here it is of 10 milliseconds. So 10 milliseconds, this total belongs to 40 milliseconds, and 40 milliseconds is of 25 hertz, right? Similarly, if we give a firing pulse at a certain angle, so we can calculate the, this is the firing angle, and from here if we go on like this up to here, we can get this is total is 40 milliseconds, right? So this way we can check it out. And here this one is different, because here we have got 10 milliseconds, and you can see that here we have, this is 20 millisecond, that means it is 50 hertz. And here we have, this is the pulses of this with the firing angle alpha, and this one is also we can get at certain firing angle. And here we have seen the pulses over here for the 50 hertz. What we can see, the 1 and 3 is being used for 50 hertz, and here what you can see is the all the 4 pulses there, and this is a pattern what you see in the simulation, that 1 and then 3, then 4, then 2 in this pattern. So here we get a pulses like this. So this is for the 25 hertz, and this is for the 50 hertz. Hope you have understood